Hello everyone, thank you for coming back through this last few sessions of CYSAT 2026. I hope you all had a great time already. But today we're going to finish with some last talks regarding defense and sovereignty. Before I introduce our first speakers for this afternoon, I would like to highly recommend everyone that hasn't yet to install the app, because we will have some interactive sessions during this talk for which you will be needing the app. So please, if you want to participate in our interactivity sessions, thank you very much for installing. So our first talk, we have Christian Kloch, technology lead from Force Technology, who specializes in critical communication, 5G, cybersecurity for both ground and SATCOM-based systems, and Michael Berger from the Technical University of Denmark, who is an associate professor in communication network engineering with a focus on deterministic and secure networking for critical applications. And they will be talking today for us about DIPS in space, which, if I understood correctly, is distributed intrusion protection and prevention. Correct? Perfect. Take it away.
It works. So, first of all, thank you for coming to this event. I mean, it's great to see you all. And I mean, if you can't see our slides, all the first row is actually empty. So, please come closer. As said, my name is Christian Kloch. I work for Force Technology. Michael?
Yes, from DTU.
And as said, the title of our presentation and actually our project that we are running right now is called Detecting Intrusion and Protect System in Space. And it's a 1.5-year project, and we are almost 6 months in this process. And actually, we also prepared a poll that you really hope that you fill in at the end of this session, because we need your feedback, because we have some good colleagues at home who are actually expecting to get some insights from this community. So please download the app, answer our poll. That would be really kind of you. First, a few words about why, and actually why we actually entered this project. And I mean, we're probably all aware of why. But I mean, we heard a lot about the satellite plays a crucial role in modern society, both for the military and for the civilian applications. We also heard that it would grow quite significantly over the next 10 years, which is great. But we also know, and that's something we realized when we were here last year, that the cybersecurity part, it's not really, it's been looked at, but not as much as we actually was expecting it to be looked at. And that's the reason why we say, okay, there's an area here where we need some more focus. So, and again, that's the background for our project. And all the thing is very important here is that since we are seeing this area grow as we are, we will see more and more smaller companies coming into the ecosystem. And in Denmark, as a reference, we have about 240 companies that actually involved in the space ecosystem. And as you can imagine, I mean, all these small companies, they need some guidance on how to apply and think about cybersecurity in the products, and also to be compliant with the requirements for these bigger satellite projects. And so therefore, we have the ambition that we want to increase the awareness about cybersecurity measures. I mean, what should you be aware of? Where should you be aware of in the process, and so on? And what can you actually think of as a smaller company? We also want to integrate measures. So talk about how secure is my solution. And then we want to apply anomaly-based methods on the satellite. We're fully aware that the satellite versus, I mean, compared to the ground station, is a unit with a lack of power. Of course, it has power, but has limited power resources. It also has limited computational resources. So how do we then apply AI in a reasonable way to get the benefit, but also still having the power budget and the computational budget into consideration? And when we started this project, I mean, this project is actually a collaboration between 4 partners. We have DTU, with Michael, Force Technology with me, Alexander Institute is another RTO in Denmark, and then we have a company called GomSpace. When we launched this project in Denmark, we got a lot of attention. And actually, one of the biggest newspapers in Denmark, they reached out to say, okay, please share what you're doing. And that's the reason why they made this article, talking about how can Danish companies provide solution for being more cyber resilient in the product. Another thing I want to add here is actually the reason why we have engaged with a company is actually that all the things we develop in the project can actually be applied in real life, so we can get some actual feedback on how good our solutions are performing. So basically, I know you all know that, but I mean, basically, I just wanted to show what a satellite system looks like. I mean, of course, we have satellites in space with the communication in between. Then we have a ground station and the ground dish and our ground control center. And when we think about cybersecurity protection, it's not only about the satellite itself that is in orbit, but it's also about all the entire path until you get the satellite into orbit. So think about cybersecurity when you do the design, when you do manufacturing. I mean, looking to how many companies are actually contributing to this satellite. It's actually quite enormous. It's not only a single company, but you, as a company, you buy a component from other companies that buy something from other companies and so on. So actually, quite a number of entities involved in this satellite or putting a satellite into orbit. Then it's about test, transport, launch, operation, and also decommissioning. Because I mean, as we hear that satellites or bits and pieces from the satellite will be reused if possible. And this process you can find in this German document from BSI called Information Security for Space System, which we recommend. So one of the things we have developed so far is our STARM template. I want to call it the Satellite Threat Assessment and Risk Mitigation template, which we will use in dialogue with companies to say, okay, we want to help them identify potential risk and causes. We want to recommend how to avoid the risk and what can you do to do in that case. And then, of course, also promote the AI solution that we are developing as part of this project. The picture shown on the left-hand or right-hand side is from the website. So if you want to read more about this project, please take a look, and you'll find more. The STARM tool, as I said, it's a tool that is applied for each and every company, where we simply try to address these issues. And of course, there's a meaning of that. I mean, we heard during the last couple of days that we don't want to lose command and control to our satellite. We don't want our service to disrupt, and so on and so on. Some of these consequences that may appear in case you get attacked by a cybersecurity attack. And just to show you a glimpse of a tool, I mean, it's a tool that content-wise depends on who you talk to. But we actually look into the threats both from the hardware side, from the software side, and also the network side. So hardware, that's hardware on the satellite. Software, that's software on the satellite. And network is, of course, the communication between the satellite orbit and the ground. And for every threat, we look into how can you avoid this threat. And some of them are pretty obvious, but it's here mainly for illustration purposes that if you want to avoid any hardware backdoors, I mean, of course, you should look into secure chip design. If you, I think that's one example. If you want to malware, is that an issue? Look into the file systems, and of course, if you take into jamming, look into applying frequency hopping. But it's also important that the tool takes into account who is responsible, because that's sometimes we miss when we talk about risk. We talk about there are some challenges, but we forget to talk about who should actually do something about it. And that's why we have identified the different risk handlers or different responsible persons, and also when in this process they should actually engage. As I said before, that is this 7-step process promoted by the BSI. So, okay, where should we actually take an action? So up to you, Michael.
Okay, thank you. Yes, so as Christian mentioned in the beginning, the scope of Deep Space is to develop this intrusion detection and prevention engine, and to develop and validate that, we need to go from how to go from simulation to onboard detection. Yeah, we use the NOS3, free of use platform, open source platform from NASA. There was a nice workshop yesterday that maybe some of you attended. I attended it, and now I understand my own slides much better. But NOS3 is basically a full simulation of a satellite. It includes, the flight system software, the ground station Cosmos, simulated environment, a physical simulation module that sort of gives input to the satellite. So in total, you can simulate a complete mission in NOS3. And this is a really good starting point for doing the developments. I can also check this one. So taking a closer look at the satellite, the flight system software. This is in NOS3. It's based on the so-called core flight system, also open source from NASA, used on many satellite missions. And the core flight system is basically built around a pile of processors here, communicating over a shared software bus. So this software bus gives us a really good opportunity to monitor everything that goes on, and to use that as you can say, central point of capturing data for our intrusion detection system. As you can see here, this is some visualization of the data captured over this bus. As a first step, we try to use a commercial or widely used CM system for cybersecurity systems. Of course, on a real satellite, that will be too sort of complex to run, but it gives us some nice insight to start with. So what we want to do with this setup is first to have a baseline scenario of you can say goods traffic to train our models to detect anomalies. Later on, the step we will go further and develop attack patterns, and we hope, of course, to the highest extent possible that the developed system will be able to detect our attacks. For developing the attacks, we also look closely to the Sparta aerospace Sparta framework. There's also been several presentations about that until now, and this is a really useful guidelines, because they define threat over many satellite lifetime phases. So this is a good starting point for developing these attacks that we also want to detect later on. So in our effort to model the attacks, we'll primarily focus on supply chain and update-based attacks, because these are probably the hardest one to avoid completely, because especially for supply chain, it's really complex for satellites, as we have heard several times. So being completely sure that there is no sort of malware or inside the satellite is hard to avoid. And this is also where such an intrusion detection system will make sense to have in place. And of course, regularly updates are also performed, and that can be a key, a source of new malware going into the satellite, as for instance, what happened with the CYSAT attack. To validate you can see the concepts that we do here, we also need to execute that on a realistic platform. You can say this is a module from our partner GomSpace that is used for the onboard computer of the satellite. So we know that this is basically our restriction. We can develop fancy algorithms, etc., but still have to run on a module with these capabilities. And here, this is an FPGA-based platform with a sync FPGA from Xilinx and an ARM Cortex A9 processor. So quite limited in resources. I think the FPGA has up to 80,000 logical elements. So it's a flexible and good platform for doing also AI applications, but still quite limited in resources. So we were looking into algorithms that are suitable for on-board execution for doing this intrusion detection by anomaly detection. So there are basically, overall there are three main methods to pick from, like statistical methods, sequence-based techniques, or machine learning, like AI-based approaches. And in reality, a combination here would make sense, because the benefit of the statistical and sequence-based techniques are that they are sort of very low cost, easy to implement, and they can still detect quite some abnormal conditions. On top of that, of course, to make it even more robust, some machine learning techniques, either based on isolation forest or deep learning autoencoders, are popular choices, and also incremental PCA for anomaly detection. This figure here shows an example of how these isolation forests trees are built. And on the FPGA, or the platform, the computational platform, the FPGA combined with ARM processors gives us a really good opportunity to do, for instance, feature extraction in the FPGA hardware and the actual interference in the ARM processor. To do some initial investigation and validation of the complexity of implementing the AI algorithms, we looked into the ESA OPSAT benchmarking study for anomaly detection, which is publicly available, and the dataset can be downloaded. For that dataset, I think 14 different features are defined. And you can say, when working with anomaly detection and machine learning, one of the really important things here is what kind of features are you looking at, because you never get better than results than what you sort of feed into the algorithm. So looking at the right thing is a quite important task to identify. Here, with these features, some of them are quite complex based on statistics, peak detection, and so on, but and they refer to 3 magnetometer channels and 6 diode channels. And what we tried to do was to do an FPGA implementation of those to see, okay, what is the resource usage for such a system. And again, we could actually see that with around 15,000 LUTs, we were just filling up a smaller corner of what this GOM-based platform could supply. So that was quite uplifting, because we can see that we can actually do more advanced feature extraction even on these platforms that you use on board smaller satellites. So to summarize, we can say we have come up now, we think ourselves, with a good approach based on Sparta and using NOS3 and core flight system from simulation. We have a really good platform for continuation here of our study, building training algorithms, introducing threats, and figuring out whether we can detect those. So until now, you can say we have identified this central bus in the core flight system as a really useful observation point for doing the work on intrusion detection. And our first study with the ESA OPSAT telemetry dataset, we have also been able to show that these algorithms can actually be done in a feasible way and fits well within the boundaries of the platforms that we can work with in space. Yes. So Christian, you have a little...
Yes, I have a little poll that I want you to run. Can you start it? Yeah, it works. Great. So please provide your input, because, I mean, we all are aware that the capacity of our satellites is limited, and we need to find out exactly where we should put the spot. I was 50-50. Can we? Let's go one way or the other way. Hmm. Can we see how many have answered actually? 7. I can see 1, 2, 3. I mean, please. 15 should be possible, I would say. Yeah. It's good to see there's some diversity now. Now we have all 3 items on the chart here. That's great. I think a clear winner, yeah. Cool. Can I just ask? I just want to ask, and I hope it's okay that I bring you to spotlight, so to say. One of you who have mentioned this A, could you please put a few more words to it? Oh, somebody want to raise their hand? Oh, yes, cool.
I have a microphone.
Yes, so I picked A just because I believe basically transmitting this internal communication to the ground in its entirety and monitoring it there is usually not feasible because you have some constraints, so you could only really monitor it on board and nowhere else. So I picked A.
Thank you. Anyone else who want to put a few more words to it? Okay. Completely silent. You can actually impact the project if you can share your thoughts behind. Okay. Super, can we go for the next one?
Next one.
Yeah. Wasn't there 2? Yeah. One vote. Perfect. Hmm?
Give a few more seconds.
We need 15 as well.
Exactly.
15 is a good number. I'm getting closer. We closer to.
I need one more.
One more, please.
Yes.
That's perfect.
Perfect.
And maybe we could do the same thing as we did for the last poll. Somebody who said A, could they add a comment to that? Oh, you're silent. If I said it, I don't have a prize. I really apologize for that. But if I had a prize, would then somebody say something? No, okay. I don't think I can get a quick comment. Yeah, you have. Yeah.
Yeah, perfect. We will give him a prize after.
Yeah, well, it really depends on your threat model, but if you have a bus which usually is not trusted in the communication chain, well, then it might be like if it's trusted and you have someone that is a threat actor on the bus, then you have a big problem. So lateral movement is one of the riskiest scenarios, well, in my opinion, especially in multi-tenancy cases in like some platforms have.
Thank you very much. I think that's all from our side.
Perfect. Well, in that case, are there any questions for our speakers? Or were they so clear that... No questions are required. Yes. Okay, I'm coming your way.
Just, I wasn't clear on your anomaly detection. So you're detecting via statistical analysis, but then how do you differentiate between technical anomalies and security anomalies?
Yeah, this is of course a good question because that will be you will most likely see both and you will see both. You can see technical anomalies like sensors showing odd values, even if but it's hard to distinguish. Is this a software? Is this a supply chain attack that a sensor gives you an odd value, or is this just a faulty sensor reading, for instance? So I agree that it can be difficult to distinguish these two situations.
Maybe just a question more to you, actually.
To me? Oh.
Yeah. Because, I mean, will you share the presentation with all of us afterwards?
Mm-hmm.
That's good. Because, I mean, if you have any more questions, well, please send me an email, and I will, if it can be to me or to Michael or somebody else in our team, I mean, please share with us your ideas, your questions, and then we will try to go back to you as soon as possible.
Thank you so much indeed for everyone that wants to participate in a real research project. Please share all your inputs directly to our two speakers here. Thank you very much.